This is the review for the Unit 4 test in Enhanced College Algebra. For the first two problems, we're solving the equations using substitution or elimination, whatever you prefer. I'm going to use elimination, actually, on both of them. For the first one, I'm going to multiply the top equation by a -6. So that'll change it to -6x plus 6y equals -12. So now if I add these two equations together, that'll eliminate the x's and I get y equals 4. So I've got the y by itself. Then I just need to plug in y somewhere to solve for x. I would maybe plug it in right here. That would be x minus 4 equals 2, which means x has to be 6. And remember, you can always plug those x's and y's in to check each equation, each original equation, and it should work. On letter B, I'm going to multiply the top equation by 2. That'll give me -4x plus 8y equals 14. If I add these two equations together, the x's and y's eliminate, and I'm left with 0 equals 10. That is a no solution problem then, which means also this is an inconsistent system. Oops, try to spell that correctly. On number 2, we're going to use Cramer's rule to solve the system. So first thing with Cramer's rule is to find D, the determinant of the coefficient matrix, which would be the 1, -4, -6, 3. And remember, to find the determinant, we multiply diagonally, so 1 times 3, minus, we multiply diagonally, -4 times -6 would be 24. So we end up with -21. Now I find d of x. Remember, that means I replace the x coefficients with the constants. So that's going to be 4, -9. The y coefficients stay what they were. This will end up giving me 12 minus 54. Which is -42. And lastly, we find d of y. That's where we change the y column to the constants. The x column goes back to the x coefficients. And when we multiply diagonally, we're going to get -9 minus -16, which equals 7. So now to actually get the x and y, we take dx, -42, divided by d, -21. So that'll give me that x is 2. dy divided by d will give me the y, which is -1/3. So my solution set, or my solution point, is 2, -1/3. Number 3, we're subtracting two matrices, or you can think of it as adding a negative matrix, doesn't really matter. First thing is to check that I can actually combine them this way. They have to have the same order They're both 3 by 2s. So we're good. They both have 3 rows, 2 columns. So I would do this in pieces. 3a, that's a scalar multiplication. It just means multiply every number in A by 3. So that's going to give me 12, 33, -6, -3, 27, 9. Now you have options here for B. You can either just have B as it is and subtract, or, and this is what I'm going to do, I'm going to take this negative B and think of that as I'm multiplying B by a -1. That means that I'm going to have accounted for the negative, which means I'm going to actually end up adding the matrices. So basically, I'm taking a negative and distributing that negative through matrix B. I'm going to change all the signs. And now since I've accounted for the negative, now I'm actually just adding the matrices. And I just add corresponding elements. And you get this result. For number 4, we're multiplying the matrices together. So A times B, I have to first check, can I multiply them? A is a 3 by 3. B is a 3 by 2. Since the middle numbers match, we can multiply them, and my result will also be a 3 by 2. So I know I can multiply A times B, and I'm going to end up with a 3 by 2. And so remember, with your first matrix in multiplication, you're using its rows. For the second matrix, you're using its columns. And I'm going to multiply corresponding numbers together and then add those results. So this means 7 times 2. And this would just be all side work here, 14. 5 times -4, so that's -20. -4 times 1, -4. And then I add all those together, and that would give me -10. Then I go to the second column. So I'm going to have 7 times 0, 5 times 6, -4 times -1. Add those together, 34. I've gone through all my columns for the second matrix. So I reset, jump down to the second row, back to the first column, and repeat. So this would be -2 times 2, -4, 5 times -4, -20, 1 times 1, and so I get -23. Hop to my second column. -2 times 0, 5 times 6, 1 times -1. Add all that together. I've gone through the columns again, so I reset, jump down to the third row, and restart. Fortunately, I am on the last row, so I've just got 2 numbers to find here. So 10 times 2, -4 times -4, -7 times 1, and that'll give me 29. And for the last entry, 10 times 0, -4 times 6, -7 times -1. Put those together, and I get -17. So it's a slow process. You won't have a lot of those to do on the test. Just take your time, double check your numbers. It's It's very easy to get lost in the numbers. For the next problem, it wants b times a. Again, I have to first check, can I do it? B, 3 by 2. A, 3 by 3. The middle numbers don't match. The columns of the first and the rows of the seconds don't match, so this is not possible. And for letter C, it wants the determinant of matrix C. So determinant of C, that's very simple. That's just the multiply diagonally. That's going to be -2 minus multiply diagonally. That's -21. Careful, that's going to become -2 plus 21, 19. On the other side, we're doing a lot of the operations on matrices. Obviously, not matrices, functions, including composition and all the other operations, addition, subtraction, all that fun stuff. So 5a wants me to find f plus g of -2. This means find f of -2. Find, let's use another color. Find g of -2 and add them together. So f of -2 just means I'm popping -2 into the function. That would be 4 plus 8 minus 3, which is going to give me 9. Pop -2 into the g function. That's going to give me 4 plus 5, 9 as well. And so I get 18. Similar type of problem on letter B. I'm going to find f of 3, and I'm going to subtract off g of 3. So f of 3, if I plug 3 in, that's going to give me 9 minus 12 minus 3, -6. G of 3 is going to give me -6 plus 5. So I'm subtracting -1. So I'm going to end up with -5 for a result. For the next one, I'm dividing. So there's going to be f of 2 divided by g of 2. If I plug 2 into the f machine, that gives me 4 minus 8 minus 3. So that's -7. G of 2 is going to give me -4 plus 5. So that's 1. So -7 divided by 1, -7. The next one is a composition. So remember, think of these kind of right to left. I'm going to plug 1 into the F machine. So if I plug 1 into the F machine, that's going to give me 1 minus 4 plus 3. Oh, excuse me, minus 3. I don't know where I came with a plus 3. Sorry about that. So that's going to be -6. But now that -6 becomes the input in the G machine. So now I'm plugging -6 into the G machine, and that's going to give me 12 plus 5 for a result of 17. For letter D, now we're doing f times g of x. So I'm not plugging in a number. Since it's the generic x, that means that I'm actually going to be multiplying the functions together. So I'm going to make a little room here. Oops, that's not what I wanted. Bring these up. So f times g of x literally just means do f times g. So x squared minus 4x minus 3 multiplied by negative 2x plus 5. So this is kind of like a super duper FOIL problem. X squared, I'm going to multiply with negative 2x cubed plus 5x squared. Okay, next I'm going to multiply the negative 4x to all the blue stuff. So that's going to give me 8x squared minus 20x. And lastly, I'm going to multiply negative 3 to the blue stuff. That's going to give me plus 6x minus 15. From here, I just need to combine any like terms, and I end up with a result of negative 2x cubed plus 13x squared minus 14x minus 15. Now notice letter E looks very similar, and actually I just realized I had 2 letter D's on this. Oh well, no worries. For letter E, it's composition though, it's not multiplication. So for letter E, f of g of x, this means take your g function and plug it in wherever you see an x in the f function. So I'm actually going to take negative 2x plus 5. I'm going to pop it in there and there. So what is this going to look like? This is going to be negative 2x plus 5, squared, minus 4 times negative 2x plus 5, minus 3. So from here, there's just a whole lot of multiplying and foiling out and just being very careful of what I do. So negative 2x plus 5 squared, this part, be careful, you'd have to actually FOIL that, multiply it by itself. If you did that, you would end up with 4x squared minus 20x plus 25. On the next part, I have negative 4 that I'm distributing through. That's going to give me 8x minus 20. And then I still have the minus 3 at the end. Combining like terms, I end up with 4x squared. See, minus 12x plus 22. For number 7, we're given some function h of x, and we want to basically decompose this function into 2 pieces. So I want to turn it into 2 functions, f and g, such that if I compose those functions with each other, it would give me h. So this square root 7x minus 5, that's the result. I want to backtrack and figure out what could 2 functions be that turned into that. Here's one option. The first function could be square root of x for f. The g function could be 7x minus 5. So that's a possible answer, because if I took 7x minus 5 and I plugged it in for x, it would give me the original function, the original h function. There is another option here. You could make your f of x function square root x minus 5. If I did that, my g function would be just 7x. Still works, because if I take 7x and plug it in for x, I get back to the original function. Number 8, we're looking at an inverse. So for the inverse, this f of x, we think of it like a y. We switch the x and y. So this will be x equals the cube root 2y plus 5. And now I'm just going to solve for the new y. So the first thing I've got to do is get this cube root out of here by cubing both sides. So at this point, I'm at x cubed. I just eliminated the cube root, so now I have 2y plus 5. My next step would be subtract off 5. So that's going to give me x cubed minus 5 equals 2y. And the final step would be to divide by 2. So now y is by itself. And it equals x cubed minus 5 all over 2. And again, with it being a inverse, instead of calling it y, I could call it f inverse of x. Now for the last one, we're going to verify that these are inverses of one another. So it says on this last one, we'll call that our answer function g instead. So I have two functions. I have my original f of x function from number 8, cube root 2x plus 5. And I have my g of x function, which is the inverse that I just found, x cubed minus 5 all over 2. Composing these with one another should, in both cases, lead to x as a result. They basically undo one another, and I get x out after putting x in. So the first one is to take g of x and plug it in for x in the f machine. So what this is going to look like is the cube root of 2. Oops, let's change colors here. 2 times the quantity x cubed minus 5 over 2 plus 5. So again, I took the red function and I replaced x with the blue function. And now this boils down, 2's cancel. So that leaves me with the cube root of x cubed minus 5 plus 5. Minus 5 plus 5 is gone. So now I'm left with the cube root of x cubed. Cube root and cubed cancel out, and I'm left with x. That is what I was supposed to get. But to prove that they're inverses, I have to also go the other direction with it. Meaning I have to take my f function and plug it in for x in my g function. So what this is going to look like, cube root 2x plus 5 cubed minus 5 all over 2. Again, this is my second part. The cube root and the cubed cancel out, so that would leave me with 2x plus 5. And then I still have minus 5 all over 2. Plus 5 minus 5 is gone. So now I'm left with 2x over 2. 2's cancel. And lo and behold, I'm left with x. So composing it, f of g and g of f both result in x. That verifies that they are inverses.